Tonight on Catalyst, can we really make it rain?
We have the first hard evidence that cloud seeding actually works.
What's the big deal in Copenhagen?
Our future depends on what governments can reach an agreement on in Denmark.
And our brand new royal institution.
In this old stock exchange, something is happening that will transform the way science is talked about.
G'day, welcome to Catalyst. Over the last few years, there's been rising speculation over whether we can engineer the climate, manipulate the atmosphere to help counteract some of the adverse effects of climate change. Can we, for example, make it rain and offer some relief to the drought that's been gripping the southeast of the country for more than a decade? Well, some research scientists have been examining the cloud seeding program in Tasmania and reckon the idea is well worth investigating. I recently caught up with them and checked out their results.
These are the vast snowy mountains in New South Wales. When all this melts, it flows into our dams and rivers. Vital water for farmers and, of course, the environment. But at the moment, times are dry. So, an interesting experiment's going on here to see if water levels can be increased. The experiment starts when the conditions deteriorate. The skiers head in, this science journalist heads out, and the weather turns from bad to atrocious.
A cold front is passing through here. It was -6 degrees this morning. The wind gusts more than 120 kilometres an hour. Perfect conditions for cloud seeding.
The clouds here are being seeded to make them drop more snow than they otherwise would.
This is one of your monitoring stations up here?
Yeah, it's one of our remote sensing facilities up here at Bluecraft.
Laurie Warren has been snowmaking in these mountains for almost 5 years.
So far this year we've seeded about 107 hours of operations, so it's been quite a good year so far.
The seeding's done by these burners. There are 23 of them dotted across the mountain. Their flames release the seeding substance, fine particles of silver iodide. Getting the chemical up into the clouds is easy. The winds here are orographic. They push up the side of the mountain.
As the air mass moves past, we release the seeding agent and it just gets swept up within that orographic cloud. So the air that's actually moving up over the mountains and then gets swept up into the cloud.
To see how seeding a cloud makes it rain or snow, it's best to get out of the cold and build a cloud in a box.
No.
Right, how do we make the cloud?
No, to make a cloud, we just blow in. Air contains a lot of moisture.
Look at your hand. Oh yeah, look at that.
The moisture in our breaths makes this fog, a cloud of tiny water droplets.
Now we've got a cloud just like we find out in the sky.
The droplets, like in a real cloud, are super cool. Their temperature's below zero, but they haven't turned to ice.
The freezer is very cold, about -10 to -20, but the droplets are not freezing.
Okay, so that's like a cloud that's up there that won't rain at the moment.
That's correct.
A small amount of dry ice is used to seed the cloud. It causes some of that super cool water to freeze.
Oh yeah, you can see the trail through there.
Ah. Can you see what's happening?
Oh, look at that, you can see the lumps of ice forming. Yeah, gee, it's remarkable.
The ice crystals grow, eventually becoming so large they fall. In the real world, they then become rain or snow, depending on the temperature below.
All the ice crystals are already gone out, have already fallen out to the ground.
Yeah, and we have rain.
We have rain.
No lightning though.
No, we don't make lightning.
Now, the principles of cloud seeding have been known for a long time. They were first applied in the 1940s, and Australia's CSIRO was one of the pioneers.
Under suitable conditions, rain may be precipitated by treating clouds with various substances.
And back then, they actually did use dry ice.
The material most often used is solid carbon dioxide. commonly known as dry ice. The dry ice is first broken up into small pieces and loaded into a plane. The Royal Australian Air Force is cooperating by providing flying facilities for this work.
The scientists flew their plane just above the clouds that contained a lot of supercooled water.
When all preparations have been made, the dry ice is placed in the chute and the aircraft makes a run at the cloud, where it drops the dry ice at a predetermined spot.
The dry ice was later replaced by silver iodide, and CSIRO did experiments throughout Australia in the 1950s, 60s, 70s, 80s, even the 1990s. But they never found any really hard evidence that a significant amount of extra rain could be created. Skepticism grew.
In the United States, they invested heavily, and it all has been pretty unsuccessful. Here in Australia, it was invested quite heavily, and very, very spotty results to be shown for it. So, I mean, there's a huge amount of skepticism in the field, and some of it's well warranted.
It does stretch credibility a bit to think that going up there with a cloud and throwing out a very small amount of chemical, grams really, that can have an effect over a wide area.
But this cloud seeding program has changed things. Run by Hydro Tasmania, it's been going on for 4 decades, despite the scepticism. And recently, some Monash meteorologists analysed all their data.
We went back through the records, we looked at all the rain gauge data over the last 46 years, and we saw when they were seeding and when they weren't seeding, and we found a signal. We found a statistically significant signal.
Finally, the world had the much sought-after hard evidence that cloud seeding can produce a significant amount of extra rain. Meet the plane that's produced the results. It's had a few modifications.
Now, this plane flies in extreme weather conditions. It goes into clouds that a plane would normally avoid. And the problem with that can be a build-up of ice. So all the leading edges of the wings are fitted with these self-inflating sheaths. One push of a button, they pop out and break the ice off. Ice build-up can also be a problem on the front of the props, where ice breaks off, gets sucked into the engine and stops it. So a continuous ignition system has been fitted to prevent the engine stalling.
All this is needed because the pilot determines whether the cloud has the necessary supercooled water by flying directly into it.
The way they work out if the cloud has supercooled water in it or just ice crystals is ingenious. It's done with this hot wire here. If there are ice crystals, they just bounce off the wire and don't lower its temperature. If it's supercooled water, that sticks and cools the wire down.
The plane's canisters are loaded up with silver iodide mixed with the highly flammable acetone. Burning this blend produces a nice fine mist of silver iodide particles. When the right conditions are found, the burners are switched on. Only tiny amounts of the seeding chemical are needed, insignificant from an environmental point of view.
In the tanks, we have about 150 grams of silver iodide in a solution of about 27 litres of acetone, and that takes about 3¼ hours to burn, so very, very small quantities.
Cloud seeding not only has to work, it has to be cost effective. So only dams big enough to hold the extra water are targeted.
This Great Lake here is the really our prime candidate for cloud seeding because it's our driest catchment actually, but it's a very valuable water.
Right.
And the other one is Gordon, the huge storages.
Get the targeting right, and cloud seeding is economically viable.
But overall, we estimate it's worth about 3 times the cost of the program.
But it turns out cloud seeding won't work everywhere. The reason it works in Tasmania is because of this cold but very influential part of the world.
The Southern Ocean is huge. It's 15% of the Earth's surface. In the winter, is going to be the windiest spot in the world. The clouds over the Southern Ocean are very, very peculiar. They don't want to freeze. I mean, they're super cold. You get them at -10, -15 degrees, and there's still a large portion of the clouds that are just liquid. That's quite a bit of a surprise to us.
As the Southern Ocean air rolls in over southeast Australia, it encounters mountains. And in just a few places, the right conditions for cloud seeding form.
What the satellite imagery is showing is really there are 3 spots in Australia where you could do this kind of cloud seeding.
There are the already seeded Tasmania and Snowies, but the third spot is not seeded yet.
It would be in the catchment area, the Thompson. That would be the ideal location for this.
In other words, the catchment area for drought-affected Melbourne. With the drought in Victoria now in its 13th year, any extra water would be very welcome.
In Tasmania, it looks like they're getting about 12.5 gigalitres of water a month. They're getting a 5% increase over a target of about 2,500 square kilometres. If you could do that in Melbourne, I think you'd help a lot of people during this big dry.